So on last week, we talked about some of the things having to do with the sun and how the sun warms the earth and how the sun and the earth go through orbital cycles and how none of it really affects the climate. But I kind of want to back up again and talk to you about a couple of things that have to do with climate that we really sort of glossed over. And so today I want to talk about carbon cycle a little bit. And then we can relate some of that to how the buildup of carbon dioxide in the atmosphere has happened so much in the modern era. So let's see. All right. So carbon cycle, right? That's something that you all learned about in biology, right? This isn't a totally new concept, right? Carbon in the world, we know, takes on a lot of different forms. In the atmosphere, we mostly find it in the form of CO2. You know, this is not a giant component of the atmosphere. It's actually a very small percentage. I think that if we look at what makes up most of the atmosphere, diatomic nitrogen is the biggest thing. That's about 78%. And do we know what the next most common element in the atmosphere is after nitrogen, which is totally neutral, right? This doesn't interact with us. We breathe it in, we breathe it out. It doesn't really interact with us biologically all that much. It takes microorganisms turning it into other forms like nitrate and nitrite. But anyway, remember, it's oxygen. Oxygen is about 21%, something like that. And what's that add to? Well, maybe let's say 20. I'm going to say 20. I don't remember, but I know that everything else is, well, things like argon, helium, xenon, all those types of gases, all those are less than 1%. And that leaves a very few other ones. Carbon dioxide, for example, is at about 0.04% of the atmosphere. And which is why we express it in parts per billion, because 0.04% is kind of a difficult thing to think about, right? 1% is 1 out of 100. And once you start getting into decimal points on a percent, then it gets a little unwieldy. So that's why we use parts per billion. Percent is just parts per hundred, right? That's what percent means. And so parts per billion just allows us to have a smaller amount. So 0.4% is about 400 parts, parts per million. Parts per million. ppm, when you see that, parts per million. You know, other than that, by the way, what is the other thing that we can say about everything here, the 99%, not a greenhouse gas. None of these things, not greenhouse gas. These do not hold heat in the atmosphere in any way. And let's see, looking for my oxygen amount to make sure I got that right. I'm not 100% sure I did. Because there's another thing, as far as the greenhouse gases, there's a few others that I might as well mention. And let's see, they're minor players, but they have a big effect. Let's see. Well, there's methane, which we've heard about. CH4. Methane is at something like, actually I look at my notes here, 1.83 parts per million. Not a lot, right? Very small amount. So what this means is that if you want to think of it this way, out of every million molecules, really it's more about volume, but out of every million molecules, let's just think about it, actually it is that way. 1.83 on average are going to be methane. That's what that literally means. So not very much, but at the same time, where's the red marker? It also has an outsized effect. Methane is something like 20 times more powerful as a greenhouse gas. GHG, we okay if I'm writing that? I realize I started using an abbreviation without introducing it, but greenhouse gases are ones that gather heat, cold heat in the environment. There's a couple other ones. There's nitrous oxide, N2O, NO2, N2O, yeah, N2O, and that is at 0.32 parts per million.
Don't some of them not stay in the atmosphere as long as carbon dioxide?
Yeah, there's a whole science of what's called residence time, like how long different molecules of things stay in the environment, and they're all different parts of the cycle. Some of these aren't natural products. I mean, this is a natural product, laughing gas, and I don't have how much more powerful this one is, but some of the other minor players, ozone, O3. Ozone is one of those things that I talked about a little bit as far as, we know that ozone forms a layer. I showed you that ultraviolet light breaks ozone into O2 gas and a free radical oxygen. It's very important in the upper atmosphere, very not so good in the lower atmosphere. It's not good for our respiration. It's actually not good for plants, but this is why we like to keep the ozone up where it belongs. When it's down here, it's part of smog and a few other things. But anyway, oh no. Oh, that's what that says. Sorry, I couldn't read my own writing. So it's actually very, very rare in the lower atmosphere, about 10 to 40 parts per billion. So not so much, wait, is it? Whereas, and that's in the lower atmosphere. It's not all going to be like this, by the way. I'm just going to get a few things on the table here, fact-wise. And then, but in the upper atmosphere, in the stratosphere, it's about 10 parts per million. So in the stratosphere, which is where we want the ozone, it's much more prominent at 10 parts per million. And the last one I want to mention, there's one more, and it bears mentioning. It's incredibly rare. But these are what is the general name? Halocarbons. And these are entirely human-created compounds, like Freon, chlorofluorocarbons, which is what we outlawed in spray cans in the 90s to help the ozone layer, so CFCs, chlorofluorocarbons. These are, and then another one is HCFCs, hydrochlorofluorocarbons. But there are only a few, and this is the last one of this type. So there are only a few parts per billion. But they have a multi-thousand times higher effect as a greenhouse gas than carbon dioxide. So this is why we would even consider them. So they are literally thousands of times more potent.
Okay, the one that starts with an H is hydrochloroquine?
Yes, yeah, hydro and hydro C, C's, you have the rest here, so, yes. Well, that's,
Sometimes I put in fancy ski waxes to make your skis go really fast, but they were outlawed recently, so now that's not
Really?
that much of a
no
problem.
kidding. That's really interesting. I did not know that. Okay, so anyway, so those are the, that's the general players. I'll tell you, take a minute to get that, and I'm gonna hit pause on this for a second, and then we'll start up again.